This question is about the electrolysis of sodium chloride solution. A. Explain why solid sodium chloride does not conduct electricity, but a solution of sodium chloride does conduct electricity. So clearly in both cases we're dealing with ionic substances, sodium chloride. But in the solid, the ions have fixed positions and the ions cannot move. And that would get our first mark. While in the solution, the ions are dissolved in water and the ions can move when we're dealing with a solution. So in a solution, the ions can move. And that would give us our second mark. B. Predict the names of the two elements produced in the electrolysis of sodium chloride solution and describe how a student could confirm these elements were made. So we've got two jobs to do. First, to predict the names, and then to describe the tests that we would need to perform to identify them. Well, if we deal with sodium chloride first, that's going to split up to give us sodium Na+ ions and chloride or Cl- ions. But we're dealing with a solution, so we've also got hydrogen and hydroxide ions. And these were formed when water naturally splits up. Well, that means we're going to have a race towards each of the electrodes. If we deal with the negative electrode first, both of the positively charged ions, that's the sodium ions, and the hydrogen ions would be attracted towards it. But only one ion can win that race. And that's always the one that is the least reactive. So in this case, the least reactive is the hydrogen ions. So hydrogen would be released at that positive electrode. Now the question asks for the name, so I'm going to give the full name. Hydrogen would be the element that is released. And it also asks us to describe the test to show that hydrogen was indeed produced. And to test for hydrogen, we need to use a lit splint. And if hydrogen was present, we would get a squeaky pop. Let's deal with the positive electrode next. Well, once again, we've got two ions that would be attracted towards the positive electrode. Chloride, Cl-, and hydroxide, OH- ions. So with their negative charge, both of these would be attracted towards the positive electrode. But again, there's a race. The winner in this case will be the chloride ions because chlorine is in group 7. So we're going to have chlorine being produced at the positive electrode. So I'm going to write its full name as the question asks. So chlorine is the element that is produced. And to test for chlorine, we would use damp litmus or UI paper. So damp litmus, and it would go white. C. A scientist carried out a similar experiment using molten sodium chloride. Sodium and chlorine were produced. Complete the half equations to sum up the reactions that take place at each of the electrodes. The first one is for the positive electrode, and we're going to need to balance it both for the chlorine atoms, but also for the charges. We can see that we have got one chlorine on the left-hand side and 2 chlorines on the right-hand side. So we're going to need to have an extra chlorine on the left-hand side. So I'm going to put a balancing number of 2 in front of the chlorine on the left-hand side. We now have 2 chlorines on both sides. But unfortunately, the charges still don't balance. On the left-hand side, we've got a 2 minus charge, while on the right-hand side, we just have a minus charge in front of the little E minus for the electron. So we're going to need to have another negative charge. So to show that, we're going to put a balancing number of 2 in front of the E minus for the electron, giving us a 2 minus charge on both sides. Finally, let's look at the half equation for the negative electrode. Here we can see that we have got sodiums on both sides. And in fact, we have 1 sodium on either side of the equation. But unfortunately, it doesn't balance in terms of the charge. On the left-hand side, we have a 1 plus charge on the sodium ion, while on the right-hand side, there's no charge with the sodium atom. So we have a missing substance, and that missing substance is an electron. Now, electrons have a 1 minus charge, and we would just need one of those electrons to balance the charge from the 1 plus sodium ion, giving us an overall charge of 0 on both the left and on the right-hand side.